we know how much structure rules give us. So why don't we learn some more? You will enjoy this. Because as we continue to build the universe of maths, we want to keep everything in order. No more chaos. So let's see some new rules for complex numbers. For instance, how do we perform different operations on them? Recall that complex numbers have real and imaginary components where the imaginary I equals the square root of -1. Hope you can spot these now even if you see more than one complex number. Will you? Let's check that by starting with the first law. It says if two complex numbers are equal, their real components must equal each other, and so the imaginary ones. Perfect. But what about when we want their sum? Comes property number 2. Just add the real components and then the imaginary ones. Your answer will be another complex number. Simple. Similarly, the same idea will work for subtraction. It is just like adding a negative complex number to a positive one. Observe. The second number becomes negative, and then you just group the real and imaginary parts back together. Just like in this example, we rearrange the real and imaginary parts to get the difference. Moving on. How do we multiply a complex with a constant? The constant, let's take k in general, simply distributes over the real and imaginary parts. Great. But is multiplying with another complex number as straightforward? On surface, it may not seem to be. We have to open up the brackets, which gives us a lot of terms to juggle. But we can employ a simple trick, which will come in handy. Treat the I as a variable and expand the terms. Do you notice the squared I? From the previous lesson, we know that it's equal to -1. Now we are left with 2 real terms and only 2 imaginary ones, making our final answer just another complex number. Remember that as a formula of multiplication to avoid all the intermediate steps when you solve an example next time. So far, so good, right? We'll end this lesson with a special pair of complex numbers called conjugates. These complex numbers have the same values of real and imaginary parts, with just one difference. Their imaginary parts have different signs. Therefore, when you multiply the conjugate pair, something very interesting happens. The imaginary parts cancel out each other, while the second power of I becomes -1, which when multiplied by -b squared just becomes positive b squared. Conclusion? The product of a conjugate pair is just a real number. Always. You can see that better with an example, where the answer just turns out to be a nice, clean and a crisp real number 5. Like beauty, conjugate pairs can come in all shapes and sizes. Even if the real part doesn't exist, it is still a pair of conjugates, because it's the imaginary components that matter. What if you only had the real part though? A real number is a self-conjugate. This means it's just a conjugate of itself, because its imaginary part is 0. And that's all, my friends. This is going great, isn't it? We had infinite real numbers, and to those we added an entirely new type of number, one that isn't even real. But thanks to our rules, we can juggle all these varieties together so well. I guess sometimes rules aren't so bad.